So we've learned how to solve an equation by undoing an operation. So the inverse of addition is subtraction and the inverse of multiplication is division. And we always look at what's happening to the x and we do the opposite of what's happening to get the x by itself, or the variable. So in the same way, when we talk about square, the opposite of a square is a square root. So those are inverse operations. So to undo the squaring of a variable, so in this case we have the definition using n, but it can be any variable. Remember, the variable just can be any letter that's taking the place of a value. So in order to undo it, we square root it. So this means we have to do, or same rule applies, whatever we do to one side, we have to do to the other. So in this expression, we have x squared equals 16. So to undo this operation, we have to take the square root of this side and the square root of this side. So then we're left with, when we use the square root button on our calculator, it looks exactly like that. We're going to be left with x equals the value of plus or minus 4. Let's go to x squared. So we're going to take the square root of both sides. So in your calculator, there's a square root button. It looks a little different in every calculator, and usually in calculators you press the button first, but in some calculators, like if you're using your cell phone, you type in 256 and then press the square root button. And that's going to give you the answer of 16. So up here we got the answer of 4. So another important thing with square roots is we actually end up with two values that are true. So let's talk about this one, for example. So if I take 4 and square it, I get 16, which is what I want. But if I also take -4 and square it in your calculator, that's -4 times -4, right? And we know two negatives make a positive, so we end up with positive 16. So both of these values actually satisfy the equation. So we have the answer of a 4 and a -4, but in math we're lazy, so we write it like this. So there's a plus minus 4. So this would be your answer. X is equal to positive and -4. If you write it this way, that's totally fine, but typically this is the format. So we can do the same thing with the second example. We say x is equal to plus or minus 16. So typically on an assignment, we'll only take off like a maximum of 1 mark if that's a continuing error, but you need to say both values because they both satisfy the equation. And I'll make sure I'll review that as we go. Okay, so we're going to get into multi-step equations. So we've learned how to use addition and subtraction to undo operations. We've learned how to use multiplication and division to undo operations, and now we've learned square root. So we're going to combine all of that and use that to solve equations. So the rules for multi-step equations is that we deal with our addition and subtraction first. So we're going to undo our addition and subtraction first. And then the next step, we're going to undo our multiplication and division. And at this stage, we know the third step, which is to undo exponents. So you can kind of see, actually, it's the opposite of BEDMAS. So we're going to do addition subtraction first, as opposed to at the very end, then multiplication and division, and then we're going to undo exponents. So that is the square root. I should say squared exponents. So addition, subtraction, then we deal with our multiplication, division, and then we deal with our squares by taking the square root, and then we should be able to have our x. So let's look at the first example. So in this example, I have -3n plus 10 equals 64. So we're going to, first step, we're going to get rid of this plus 10, right? So our goal is to get n by itself. If it's easier for you, we can write an x in for n, but we're going to try to get used to using different letters at this level. So we're going to try to solve for n. So our goal is to get n equals something, so it by itself. So the first step is we're going to get rid of the 10, and what's happening, the 10 is being added. So the opposite of addition is going to be subtraction from both sides. right? Because whatever we do to one side, we have to do to the other. So we'll do the first step first. So again, you don't need to write out this step, but if you choose to, that's great. So we're subtracting 10 from the left-hand side, and then we're subtracting 10 from the right-hand side. So this goes away, which is why we did it. So we're left with negative 3n is equal to 64 take away 10 is 54. And then our second step is going to be to undo the multiplication and division. So we're going to look at what's happening to the end. So negative 3 is being multiplied. So we divide by negative 3 on both sides. So we're going to divide by negative 3 on this side, and we're going to divide by negative 3 on this side. So that negative 3 goes away, which is why we did it. And then we're going to take 54 and divide it by negative 3, and that gives us negative 18 as our answer. So just to recap, we did our subtraction of 10 first, then we were left with a negative 3 being multiplied by the n, so we undid that next and divided by negative 3. Okay, so we're going to do these individually, but I have all three up on one slide because it's just easier. So let's look at this example. Oh no, we just did this one. Let's look at this one then. So we have negative 2 is equal to negative x minus 5. So what's happening to the x? Well, there's a 5 being subtracted, and then remember, there's a negative 1 in front. So we don't typically write the 1 in math, but there is a 1 there. So we're going to get rid of the 5 first. So we're going to add 5 to both sides because the 5 is being subtracted. So in order to get rid of it, we're going to add 5 to this side. The 5 is being subtracted. So in order to get rid of it, we're going to add 5 to this side, and we're going to add 5 to this side. So negative 2 plus 5 gives me a positive 3, so make sure you're keeping track of that negative in front of your 2. And all we have on this side is a negative x. So are we done? No, because there's a negative 1 in front of the x. So that goes back to the previous PowerPoint where we talked about negatives. So we are going to undo that by dividing by negative 1 on both sides. So we're going to divide this side by negative 1 and this side by negative 1. That goes away. And 3 divided by negative 1 is negative 3 is equal to x. So our final answer is negative 3 is equal to x. So again, we added 5 to both sides, right? And then we divided by the negative 1 at the very end. So the biggest thing when you're doing these is doing it step by step. So don't try to do everything all at once in your head. If you can do that, that's awesome. But typically, if you're a new student, it's going to be difficult to do it all at once until you get really used to the process. Okay, so let's look at this one. So we have x over 3 plus 5 equals 12. This one looks scary because it has that fraction, right? Fractions typically, like the x's over 3, typically kind of make us panic, but don't panic. We're just going to follow the steps. So the first thing is to undo any addition or subtraction that's happening to the x. So there's a 5 being added. So we're going to subtract 5 from both sides. I'm not going to write that out on this line. I'm just going to write the negative 5 over here, just because we know that it cancels out. You can write that step every time if you'd like, but you don't have to. Okay, so 12 take away 5 is going to give us 7. Yes, 7. And then we're going to look at what's happening next to the x. Well, I can see that there's a 3 below the x, which tells me that it's being divided by 3. So we're going to do the opposite. We're going to multiply both sides by 3. So unfortunately, I'm kind of running out of room here, so I'm going to have to bring that up. Sorry. So we multiply this side by 3, and whatever we do to one side, we do to the other. That goes away. And then we're left with 7 times 3, which is 21. And my answer is x is equal to 21. So again, we just follow the steps. Do our addition, subtraction first, then do our multiplication and division, depending what's happening. And we haven't hit an example yet where we have a squared, but we will. We will get to one of those, I think, next. Okay. Oops, did I go too far? Nope. Okay, yep, here's the first x squared, or p squared. So again, if you wish to change this to x's, lots of students seem to find that easier, but we're going to try to get used to just using different letters. The process is exactly the same. It's just a letter, place, like holding a value, or sorry, holding the place for a value. So we're going to still do our steps, addition, subtraction first. So I can see that this 2 is being added here. So I'm going to subtract 2 from both sides. So I get p squared is equal to 18, take away 2. So I get p to the power of 2 is equal to 16. The second step is going to be to undo the squared, right? And the opposite of something that's squared is the square root. So I'm going to square root both sides. So I'm going to make that into a different color. Probably should have done that for more, but that's okay. So I'm going to square root this side and square root that side. So whenever I square root the letter, the whole point of it is now it's just going to become a single letter. So in this case, a single p or a single x, depending, or whatever the letter is. So the squared goes away is what I'm saying. And then the square root of 16, we can do that in our calculator, and that's going to give us a 4. But we have to remember that whenever I take the square root of something, I end up with a plus or minus of that number. So our answer is that p is equal to positive or negative 4. Okay, let's do the next one. Okay, so we have x over 3, take away 2 is equal to 10. On this one, we are going to follow the same steps. So we're going to look for addition and subtraction. Well, I can see a 2 being subtracted, so I'm going to add 2 to both sides. So I'm not going to write that step out on the left-hand side, but know that I am doing it to get rid of that 2. So we get x over 3 is equal to 12. You can also skip right to this step if you'd like. You don't have to show me every step. It's totally up to you and whatever process you're using. So now I'm looking to see what operations are happening to 3. Sorry, x. I hope we didn't do this one. Did we do this one? No, it's a little different. Okay, so the x is being divided by 3, so we're going to multiply by 3 on both sides. So it happens to be the same value we used in the last question, but it's a little bit on both sides. So it happens to be the same value we used in the last question, but it's a little bit different. It's good to have more practice than not. So these 3's cancel, which is why I did it. If they don't cancel, then I did something wrong because I want to get to x equals something. So now I just have an x on the left-hand side, and then 12 times 3 is going to give me 36. And I don't have a plus or minus in this case because I haven't had to take a square root. So my answer is x is equal to 36. Okay, move on to the last one here. Okay, so now we have 2 over 3x plus 7 equals 13. So another thing here we've talked about is we have this big scary fraction, but let's not let it freak us out. We're still going to deal with our addition and subtraction first. So we're going to subtract 7 from both sides. So when I do that, it disappears on the left, but I have negative 13 take away 7 on the right-hand side. So 2 negatives being combined like that, we're going to end up with negative 20. I still might have my 2 over 3x. There's 2 ways to tackle this. I think in the last video I talked about just extending that division sign, but I'm going to look at it just a little bit different this time. It'll save you some time. This fraction is just a number, right? It's a value. It happens to be a decimal, but it's still a number. So what we're going to do is we're just going to divide. Let's maybe change to a different color. Whoops, that's not what I meant to do. So we're going to divide this side by 2/3 and divide this side by 2/3. Now that 2/3 goes away, okay, because we're dividing by the exact same value, just like we would divide by a 2 if it was a 2. We're dividing by 2/3 because the 2/3 is actually being multiplied by x, right? Because there's nothing in between here, it indicates multiplication. So we're dividing by 2/3, and we remember that in our calculator we have a fraction button. Well, we can always add the negative after. So let's just go 20 divided by 2, our ABC button or our fraction button, thirds, and that gives me 30. So if I go back to my whiteboard, okay, so it's -20. So I got an answer of 30. Let's just put in that negative value. So it's just going to give me the same answer, but a negative, because a positive, like we're just switching the sign essentially. So I'm just going to try to get my pen to work here. So we get x is equal to -30, and that's my final answer. Okay, so that's the end of that PowerPoint.